Here is how you would work out problem number 6 from the end of chapter 7. If you haven't read that problem yet, read it now and see if you can draw a picture or a diagram that captures all the essential details of the problem. When I read it, I see a block on an inclined plane, and you're given some information about the angle of the ramp and the weight of the block. So the ramp is angled, the block is on the inclined plane. There's a force exerted on the block parallel to the surface, and it moves up the block a total distance s. So as I read the problem, I see that the weight of the block is 128 newtons, and I see that the applied force is only 72 newtons. The angle of the plane is 30 degrees, and the distance that the block moves up the plane is a total of 5.2 meters. Now, just because we might need it later, might be interesting to calculate the height of the ramp, or the amount that the block goes up when it slides up a distance 5.2 meters up the ramp. If you needed that, because you got a nice little right triangle here, the hypotenuse 5.2, angles 30, the height that the block moves up the plane would be the displacement times the sine of that angle, if we need that later. All right, so the first question is to calculate the work done on the block by the applied force F. The first thing that comes to my mind is that that's non-conservative work, so you can't use potential energy to calculate it, but the force is constant. And whenever the force is constant, then you can use the idea that the work done by the force is equal to the magnitude of the force times the displacement times the cosine of the angle between the force and the displacement. And in this case, the force and the displacement are parallel, so that angle phi, not to be confused with the angle of the ramp, is 0 degrees because the force and the displacement are parallel. So if you wanted the work done by the pulling force, you would simply take the magnitude of the applied force, 72 newtons, multiply it by the displacement, 5.20 meters, and then multiply it by the cosine of 0 degrees, but that's just 1. So that's pretty easy to multiply out. And if you do it, I think you're going to get 374.4 joules, which would round to 374 joules to 3 sig figs, since all these other things were given as 3 sig figs. I guess it's important to note too that the work comes out positive, which is what I would expect when the force and the displacement are in the same direction. Okay, so part B of the problem asks you to calculate the work done by the force of gravity. Now, while it's true that the force of gravity is a constant force, and you could use the force times displacement method to calculate the work, it would be better if you got in the habit of calculating the work done by conservative forces, which gravity is, using potential energy. And in that view, the work done by the force of gravity is equal to minus the change in the potential energy due to gravity, which is m times g times the initial height minus m times g times the final height. And that simplifies quite a little bit because the initial height, y0, is equal to 0, and the final height is equal to our variable h that we had before. So the work done on the block by gravity is simply minus m times g times h. That's pretty easy to crank through with numbers. Don't forget the minus sign. The weight of the block, remember mass is kilograms, the product of m times g is the weight, and that's what's given here, 128 newtons, that's mg, times the height. Oh, we should have calculated that up here. Let's just go ahead and do that really quick. So that's going to be equal to 5.2 meters, and then the sine of 30 degrees you do that, I think you get 2.6 meters. So we got to multiply 2.6 meters here. So the work done by gravity is equal to the product of these two, but don't forget the minus sign again. I think you get minus 332.8 joules. Or if you wanted to round it off to answer the question, minus 333 joules. Excellent. So now part C asks you to calculate the work done on the block by the normal force. Well, we haven't drawn the normal force on here, but you probably remember that the normal force is perpendicular to the plane. And the normal force is therefore perpendicular to the displacement S. So if the normal force were constant, we could use this way of calculating the work done by the normal force. But the important thing to realize is that the normal force is perpendicular to the displacement. So the work done by the normal force is equal to 0. So there we go. We have three things that interacted with the block. The problem doesn't mention anything about friction, so we can assume the plane is frictionless. Doesn't really matter because the questions were the work done on the block by the applied force, we got it. The work done on the block by gravity, we got it. And the work done on the block by the normal force, which happened to be 0. So in the last part, well, the second to last part, the problem asks you to find the total work done on the block. And the total work then is equal to the work done on the block by the applied force plus the work done on the block by gravity. And so if you add the work done here and the work done here, again, pay attention to that minus sign, I think you end up with the total work being equal to plus 41.6 joules. Just one note about rounding. I'd use the unrounded answers here, which is better, and then I end up with my 3 sig fig result rather than subtracting these, which would give you something slightly different. Okay, so there is a third part. It asks you to calculate the work done by the force if the angle between the force and the displacement was 50 degrees, I think. So that would mean that instead of being directed like this, parallel to the plane, the applied force is directed like that. So I'll leave it for you to work that one out, but it's pretty straightforward. The force is still constant. You'd still use this formula to calculate the work done by that force, except now the angle's not 0 degrees, the angle's 50 degrees. And in that case, the work done by gravity surely wouldn't change, and the total work would be slightly different. I hope that helps.